3-1, we're gonna finally get the payoff. We're gonna look at conditions for triangle similarity. So chapter 2 so far has been about reviewing triangles congruence, and then we started talking about dilations and multipliers and that type of thing to figure out, like scale factor, to figure out if things are proportional or not. And now what we're going to do is take all that information and we're going to determine whether or not triangles are actually similar or not. So a couple of things I want you guys to think about before we do this, just to reiterate some of the stuff we've already discussed. Similar triangles have the same shape but have a different size. That's different than a congruent triangle, right? So if similar triangles have the same size or they have a scale factor of 1, they're known as congruent triangles. So there is a difference between similar and congruent triangles. We want to make sure that we understand that there's a difference as we learn about similar. So there's 5 methods for proving triangle congruence, which we just got done reviewing. We learned about those in Integrated 1. Side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. There's only 3 methods for proving triangle similarity. So these are the 3 that we're going to learn and practice on. I would definitely say you probably want to write this down in your chapter 2 note sheet. Fill these in, make sure you understand. So first of all, this is the similarity sign. It differs from the congruent sign. A congruent sign would look the same but with an equal sign below it. So it's kind of just that tilde, I think it's called in Spanish. So angle, angle, similarity. And what we need to know is that 2 sets of angles are the same. That's all we need to know. We don't need to know anything else, because if we know that this angle is the same as this angle and this same angle is the same as this angle, well, triangles are 180 degrees. So if I know that 2 of the angles are the same, well, the third one has to be the same as well. And remember, when we have the same shape, that we know that they have to be similar. So in this case, angle, angle similarity is the first one we're going to look for. Next, we're going to look for side, angle, side similarity. So in side, angle, side, one set of angles are the same degree, and they connect 2 sets of sides that are proportional, meaning they have a common multiplier or the same scale factor. Again, they don't have to be the same size. The sides have to be proportional or have the same scale factor. So in this one, here we have this angle. It connects these sides. That's really important. The angle has to connect the sides. 3 times 2 is 6. 4 times 2 is 8. So I have that proportional scale factor. If it was 3 times 2 is 6 and 4 times 3 is 12, if this was a 12, then they would not be similar. So again, we're looking for that proportionality. And then finally, side, side, side is the third one. And again, we need 3 sets of sides that are proportional, meaning that they have a common multiplier or the same scale factor. So here, 10 times a half is 5, 24 times a half is 12, and 4 times a half is 2. And again, all 3 sides need to be the same. If this was a 3, it wouldn't work, right? Half of 10 is 5, half of 24 is 12, half of 4 is not 3, so that would not be similar. But since it's 2, it is similar. So just something to consider. And then as we go through this, remember, triangle similarity is different than triangle congruence. In triangle congruence, the sides have to be the same length. In triangle similarity, the sides are different sizes but are proportional, meaning they have that common multiplier, the same scale factor. So it's just such a huge deal that we understand that they don't have to be the same size. They just have to be proportional. And then for clarity's sake, please realize that the angle measures have to be the same for both. It doesn't matter if we're talking about congruence or similarity. The angles have to be the same. All right, I'm going to pause for a second. I'm going to do some direct instruction. I basically just skip what we do in CPM and just try and go straight to teaching it, and hopefully that'll help. So let's go ahead, make a little room here, and let's start going through these one at a time. And again, we're looking for angle-angle similarity. We are looking for side-angle-side similarity, or we are looking for side-side-side similarity. These are the only 3 ways to prove triangle similarity. Again, congruence has 5 ways. So the first one we're going to look at, we'll notice we don't know anything at all about the angles. So clearly I'm not going to be able to prove angle-angle or side-angle-side. The only hope that I have is to prove side-side-side. And if I'm going to prove side, side, side again, all of the angles have to have the same proportion. Now, there's a couple of ways we can do this. First, I'll do this the way I think most of you wouldn't want to. I'm going to pick the smallest side of the big triangle, and again, I will put the big triangle on top and the small one on bottom. It's real important that we sort of do that. So the smallest is 9 over 3. That gives me 3 over 1 when I simplify it. If I go to the middle, I'm going to get 12 divided by 4, right? Because I have big over small here. That gives me 3 over 1. And then finally, the last one, the big side, 18 over 6, again, had better be 3 over 1, and it is. So there we go. So I can say for sure that these are similar because of side, side, side similarity. Now, I think most people would probably look at this and say, Oliveira, it's way easier. I know that 6 times 3 is 18, so I just did 4 times 3 is 12, and 3 times 3 is 9, and that's not wrong. The scale factor in this direction is times 3, right? However, the scale factor in this direction is times 1/3. So just make sure we understand the difference between going from big to small and small to big. All right, so now let's look at the next one. You'll notice we have an angle with 2 sides. So at most, we're going to be able to prove side, angle, side. I don't need to worry about angle, angle, or side, side, side. So if I look here, again, the angles have to be the same as they are. They're both right angles. So I will just do the big triangle over the small again because I'm given this one first. The smallest side I'm given is 6. The smallest side I'm given over here is 4. A lot of times kids want to match those 6's up, but remember 6 is the small side here, 6 is the big side here. We need to match the small with the small. So if I simplify that, I get 3 over 2. And then again, if I put the big on top, I have 8 over 6. And if I simplify 8 over 6, I get 4 over 3. So are these the same ratio? Are these the same proportion? I would say no, that they're not. So I'm going to say these are not similar. And again, if you multiply 4 times 4 times 1.5, you get 6. If you multiply 6 times 1.5, you get 9. So these are not the same ratio. They're not the same proportion. So just got to be real careful when we do this stuff. All right, if we go here, hey, look, these angles are the same, but these angles are different. And a lot of kids at this point might say, well, then we must not have triangle similarity. But we don't know. I mean, we can solve this missing side. So let's go ahead and see here. If I know every triangle is 180 degrees, and if that's 72 of it, and that's 55 of it, if I'm left with, there we are, 53 degrees, and now look, oh wait, I did the wrong one, I don't want that one. And now, this angle is the same as this angle, and this angle is the same as this angle. I could fill in the last one would be 72 degrees too, right? I know that if that adds to 180, that must add to 180. So yeah, this actually is angle-angle similarity. So even though at the beginning of it, it might not have been obvious, we did have enough information to calculate. So worth sort of considering there and filling that up. So hopefully we're good on those 3. I will now go ahead and clear up some more room for myself, and we will do the last 3. Well, at least for now. I think actually there will be more in this video, but we'll see. All right, so if we look here at this one, I'm obviously trying to prove side, angle, side, right? I mean, I don't have 2 angles here, and I don't have 3 sides here. So at most I can prove side, angle, side. The angles are the same. So my small to my big triangle, right? Small's on the left, big's on the right. So 7 would go with 12 in the same way that 14 would have to go with 24. Well, think about it. If I simplify 14 over 24, 2 goes into 14 7 times and 2 goes into 24 12 times. That definitely looks like I have the same ratio, right? So I would say, yeah, on this one, my I'm going to have side, angle, side similarity. Now, interestingly, it doesn't necessarily ask you for the scale factor, but if you did want to know the scale factor, we just do some simple algebra. We know that this number times the scale factor which is unknown, has to equal this number. So I could say, all right, well, 7 times the scale factor, I'll just call it S, equals 12. If I divide by 7, my scale factor is 12 sevenths. If I want to know what that is as a decimal, it's 1.7. So 1.7 is my scale factor. So if I multiply 14 by this number, right, I should get 24. And there you go. So anyway, long story short, there's more than one way to do this, and it's okay as long as you justify it. That's what's important. So just be careful and aware of that. All right, so on this one, again, it looks like we're looking for side angle side. We're not going to be able to prove anything else. The angles are definitely the same here. So let's go small to the big triangle, 15 to 45. And if I go ahead and do that, I'm going to get 1 over 3. And then here, small over big, the 3 goes with the 9. And again, if I simplify that, I'm going to get 1 over 3. So yeah, it looks like I have side angle side similarity. And again, if you want to know what the scale factor is, take a side here. It doesn't matter which one. I'll just go with the 3 and the 9. 3 times the scale factor has to equal 9. I divide by 3. My scale factor is 3. So 15 times 3 is 45, and 3 times 3 is 9. Again, if I wanted to go in this direction, it would be the opposite. I would say 9 times the scale factor equals 3, right? I'm now multiplying in this direction. So I divide by 9, and my scale factor would be 1/3. You're going to notice those scale factors are always inverses of each other, meaning in this direction, if it was 7/12, it would be 12 sevenths in this direction. Here, if it was 3 over 1, it would be 1 over 3. So you're always just going to be able to flip that fraction upside down. Anyway, long story short, making a bit of a mess here. So there we go, side angle side, side angle side. And now we'll look at this one. And again, on this one, if you think about it, and this one is definitely going to be a little bit tricky. So we'll kind of clear some space here. The natural reaction to this one would be able to say, no, it's not, because we don't have side angle side, right? I know the angles are the same, but this is angle side side. That is not side angle side, but these are right triangles, so we should be able to perform the Pythagorean theorem here, right? So we know that we'll call this x and we'll call this y, right? X squared plus 8 squared should equals 10 squared because of the Pythagorean theorem. So x squared plus 64 equals 100. So x squared equals 36, so x equals 6. Here I have y squared plus 12 squared is equal to 20 squared. So y squared plus 144 equals 400. Y squared is going to equal 256, I think. And I believe y will equal 16. I'll verify that on a calculator. 400 minus 144 is 256, and then I want the square root of that answer, and it is 16. So there you go. So I know that 16 equals y. Now I can check, right? I was able to determine that missing side, so now I can check for side angle side, or I can check for side side side. It doesn't really matter. I'll check for side side side. So if I go here, I know that my small triangle, the smallest side is 6. The one here, the smallest one is 12, so that's 1/2. Here, if I go small to big, the middle is going to be 8 over 16. That's 1/2. And then if I compare these sides here, it's going to be 10 over 20, which is 1/2. So I've actually proved this 2 different ways. I've proved this because of side 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 similarity, or I could have omitted these sides and I could have done side angle side similarity. So either way would have been fine. I'm going to pause for a second and maybe check for another couple of problems. Well, so let's take a look at this one. This one, I don't know, that side doesn't seem super helpful. I think the best chance that we have is angles. So again, we're going to calculate. As a matter of fact, these numbers look somewhat familiar. So I'm not sure if I take 180 minus 53, minus 55. I suspect I might end up with 72, which I do. So again, we do have the idea that these are going to be angle, angle. And remember, if you can find a missing side because of the Pythagorean theorem, or you can find a missing angle because of the triangle angle sum theorem, knowing that they add up to 180 degrees, you need to find that missing side of that missing angle. Okay, so this one we are definitely going to be looking for side angle side right here. So 45 over 15, and that's going to equal 3 over 1, and 15 over 3 actually equals, what am I doing? Okay, big side, 45, 15, little side, that should be 9 over 3. So I apologize, I screwed that up. So that should be 9 over 3 here, not 15 over 3. So anyway, just cross that out. I get 3 over 1. So yeah, I would say side angle side similarity seems to work here. If I look at this one, again, I have the Pythagorean theorem. I know this is going to be a 6, right? 6 squared plus 8 squared equals 10 squared. Here, I know it's 10 squared plus, we'll call this x squared, should equal 20 squared. So 100 plus x squared equals 400. So x squared equals 300. So I have no idea what the square root of 300 is. So we'll go here, we'll get the square root of 300. And we get 17.3. So I think at this point it's fairly obvious that this is not going to be side angle side or side side side. Here, the smallest side would be 6. So I think the easiest way to compare it is this, right? 10 times 2 is 20. That's the biggest side. So the smallest, 6 times 2 would have to be 12. It isn't. 8 times 2 would have to be 16. It isn't. So I'm going to say not similar here. All right, if we go here, again, same thing. I have the same angles, but I don't know if those ratios are the same. So is 7 over 12, right? Is 7 over 12 the same as 14 over 32? Well, if I simplify this, 2 goes into 14 7 times, 2 goes into 32 16 times. These are not the same. So I'm going to say not similar. I just want to finish up with I know this video is probably running long, but I wanted to finish up with just a couple. I just think this is kind of an important section. So let's go ahead and do that. So if I look here, again, I have the Pythagorean theorem. So I'm going to go ahead and I know that this is going to be, I'll call this x and I'll call this y. So I'm going to have, I don't know why I keep opening the calculator, x squared plus 7 squared should equal 13 squared. Here I'm going to have y squared plus 14 squared equals 39 squared. And we'll just see if there's any sort of a proportional ratio. So actually I know these numbers is x squared plus 49 equals 169. So I'm going to get x squared equals 120. So x is going to equal the square root of 120. Over here, I have no idea. Actually, I think it's 196, but let's see what these equal. 14 squared. Huh, it's not clicking. I don't know why. Looks like I'm going to have to close this calculator and reopen it. So, if I have 14 squared, and if I have 39 squared, so I get 196 and 1521. All right. I need to subtract 196 from each side. Y squared. So you can see there's quite a lot of work on some of these when you have to find missing sides, but nothing we can't do. Just a little bit extra. So y is going to equal the square root of 1325. So we'll go here. The square root of 120 is going to be 10.95, and the square root of 1325 is going to be 36.4. So 1095 and 36.4. Okay, so now let's see the ratios. I wasted a lot of time here. So if you've been thinking like, man, Oliver, look, 7 times 2 is 14 and 13 times 3, right? Here is times 2 and here is times 3. Why did you do all this work? That's a great question. I don't know why, but clearly these are not similar. So I need to look for better shortcuts than the ones I'm finding here, obviously. All right, so this one would have to be side, side, side. So 7 over 10 would have to have the same ratio as 12 over 15. Hopefully we see these divide by 3 and I get 4/5. So that's not the same ratio. So I'll say not similar there. Really regret that couple of minutes. Sorry for that. This one, again, it looks like we don't have anything, but we know they add up to 180 degrees. So 90 plus 50 is 140. So this has to be a 40. And there we go. We already have angle-angle similarity. If you calculate this one, you'll see that this is 50 as well. So there we go. I think we've done enough examples, so I'm going to clip this video.